Hello, in this video I'll show you how to create a user diagnostics in CNC machine controlled by Bosch Rexroth MTX control. It is a part of series of technical videos showing functionality of MTX controller, and all those videos are available on YouTube under Electric Drive and Controls CNC Controller MTX. This presentation is a continuation of video CNC MTX, Spindle Axis type and setup. So again, we'll use a latest version of IndraWorks Engineering software and open our project from previous video called MTX Initial PLC Channel 1 Axis Spindle 1. We'll again keep this project untouched, then create and work with a copy MTX Initial PLC Channel 1 Axis Spindle 1 Diagnostics. When we look into MTX Commissioning Manual Chapter 7.8, we can find that there are 3 diagnostic systems available for MTX control. First is created only for MTX Machine Fault and Status Display System MZA. Second is available for all Bosch Rexroth controls PLC driven Pro-V message system. And the third are diagnostic messages on small operator panels, VCPs. We'll start with MZA messages. To activate them, we must go to NC configuration parameters, then basic parameters, and then NC PLC interface. Here we can see a parameter, machine status display, MSD or MZA, cycle time. When we click on the information button, we can see that this parameter sets an update time for messages, and when it is set to 0, MZA messages are deactivated. So we'll set this parameter to value of 50 millisecond, and then to activate this parameter, software automatically prompts us to restart the system. After restart, first we'll configure NC PLC interface and add data structures for MZA messages. There are 2 structures available. First is qMZA for 2048 messages, and second is qMZA extended for 8096 messages. So since 2000 messages is enough for majority of machines, we'll select a smaller qMZA. New element shows up in our NC PLC interface list, and when we click on it, we can see that this is a structure of 2048 MZA signals, type MT MZAT, and system automatically assigned to it next available address. In our case it is %QD80. This structure is ready to be used, so to test it we'll create new program, name it PR Diagnostic MZA, and select ladder diagram as implementation language. Now we can open this program, insert new coil, then just start typing qMZA and pick our structure from the list. Next, to select the message number, we just type a dot and then select it from the list. So here we can see an activation of MZA message number 01. To test it, we'll use Bosch Rexroth operation panel and activate messages using available push buttons. So first, we'll create new global variable list and name it GVL Diagnostics. We'll make sure this list will be automatically added to symbol file. Then we'll add 4 push buttons, ppdiagmza01 to ppdiagmza04, and for lights, ltdiagmza01 to ltdiagmza04. Back in our program PR Diagnostic MZA, here we'll add a contact with our push button ppdiagmza01 to activate message MZA01, and parallel coil ltdiagmza01 to verify that message was activated. Next, we'll add our program to an active task, then compile and download. After download, we can see our program running, and next we'll start VDP15 Operation Simulator. First, we can see right away new active system warning, MSD file for configured language not found. And when we open Diagnostic screen, we can see more information about this message. So beside main message text, we can see what caused our warning. In our case, after we activate MZA Diagnostics, system is looking for additional text file called mzatexte. We can also see how to recover, and in our case, we need to create this file and copy it into root or FEPROM directory. But first, let's see if our new logic works properly. So we click and hold for 3 seconds Virtual VAM selector. That will put our push button panel into edit mode, and then we'll open editor for first available push button. Here we'll put our light ltdiagmza01 as variable LED and push button pbmza01 as variable key. The text on a button is Diagnostic MZA01. It will work direct, stay on permanently when we push it, and we'll set text size to 12. So here is our button. Next, we'll exit configuration and move our operation panel to simultaneously see PLC logic. Now, when we push our button, we can see contact pbdiagmza01 active, setting our qMZAext01 output and supporting light ltdiagmza01, and activating a new message number 1, but please note it is without any description. So we can see that our initial activation and logic for MZA is working properly, but we are missing a message definition file. It is a text file containing message definitions and further detailed descriptions. Since MTX control supports different languages, this file also can be written or translated to selected language. This file name must be mzatexte with extension depending of user language and located in MTX internal directory usrfep. So in the next step, we'll create new text file and name it mzatexte.xxx. But please remember, before closing our project, to load changes from operating station. Next, we'll open new text file using Notepad and type message definitions following this structure. So first is a message type, and it is E for error, W for warning, and M for message or note. So our first definition will be an error, and it starts with letter E. Next is a message number. Here, for every definition, we must set an unique number, range from 1 to 2048. So we'll start with number 1. Next is a message text limited to 128 characters. So we'll put a text, for example, error 1 activated. Next is a description of cause of our error. It is also limited to 128 characters and must be separated from main message by 2 pound signs. And the last part of every message definition is remedy text. It is also limited by 128 characters and also must be separated from cause by 2 pound signs. Next line is an example of warning starting with letter W. Next is an example of message or note starting with letter M. And the last definition is a second error. Next, we'll save this file as mzatexte.xxx and place it in a special MNT directory. This directory was created during software installation and can be accessed from both PC and control side. Back in our project online, then NC file system, here we can see our MNT directory, and inside there is our mzatexte file. When we click on it, file opens up and we can edit it here. For this file to be activated during control boot up, it must be located in usrfeb directory. So next, we'll simply copy and paste it there. Please note that all files in this directory cannot be edited and can be opened only as read-only. So when we need to modify this file, we must edit it in MNT directory and then copy back to usrfeb directory. Next, to activate all those changes, we must restart the system. After restart, we'll test it using Operation Simulator again. So now, when we activate our MZA01 message, we can see that it is an error and message definition shows up in a header. Then when we switch to Diagnostic screen and activate this message, we can see also cause description and recovery information from our message definition file. So let's go back to our program PR Diagnostic MZA and add logic for additional messages. First, we'll add a toggle function block so we'll be able to set and reset every message. So we'll insert empty box, then pick from library RIL utilities a function block IL toggle, name it toggle MZA01, and use function remove unused function block call parameters to leave only execute input. So here's our modified logic rung for MZA message 1. Next, we add similar rung for message 2, then a rung for message 3, and the last rung for message 4. Next, compile then download, and we can see our logic running. Next, we'll open our Operation Simulator again and add additional buttons for our tests. So we'll copy and paste a button for a Diagnostics MZA01, then edit it, then change variables for key and LED, and change button text to Diagnostic MZA02. Next, we'll do the same with buttons for message 3 and 4, then exit configuration, and we are ready to test it. So again, first we'll switch to Diagnostic screen, then activate message 1, and this is an error. We can see error icon and message text color is red. Next, activate message 2, and this is a warning. We can see warning icon and message text color is yellow. And then activate message 3, and this is a note. So here is a note icon and message text color is green. Please note that in default operations screen configuration, active warnings and notes are showing in second header line, and when multiple are active, they will alternate every 3 seconds. Errors are showing in the first header line, and when additional error is activated, the last one is showing in our header. We can change it. To edit first line in the header, we point on it and hold for at least 2 seconds. Editor opens up. Here we can select what type of messages will show up in this line. We'll leave it with default only error selection. Next, we select icon to show up with message text. Deselect only last message selection. And change message changing time to 100 milliseconds. Our changes take effect right away. We can see message text alternating, but maybe a little too fast. So we open editor again and set a changing time to 1 second. So our first line works properly, and next we'll edit a second line. Here, the only thing we modify is icon selection and set a changing time to 1 second. So we can see our MZA messages working and showing properly. And in our standard diagnostic screen, there is a ready button for Logbook. But when we click on it, this message shows up. So we'll minimize operation screen and go back to our IndraWorks project. Then click on the VDP 15 tab, and here is a Logbook configuration tab. But before making any changes here, please remember to first load changes from operating station. Now we can click on this Logbook tab and then add Logbook. New tab shows up, and when we click on it, Logbook editor opens up. Here we can select how many messages will be recorded, and we'll leave it at default 500. Next, we'll select our control IndraMotion MTX for messages to be recorded from, and then we'll select all types, errors, warnings and notes to be recorded. Operation Simulator is already open, but for our changes to take effect, we must start it again. System will automatically update visualization data, and our operation screen is ready to test. So, our messages are still set, and right now, for our test, I would deactivate and activate some of them. Now when we click on Logbook tab, we can see a history of our messages. If needed, we can also export this logbook and save it as ASCII, CSV or XML file. This test concludes our MZA diagnostic video. Thank you for your attention.